Hello grade 12s, welcome to my channel. Let us have a look at this question. This is a question on functions. This is usually one of the most challenging questions on functions in paper 1. I've taken this from Northwest trial paper from last year. So we're going to enjoy this one together. What made me attracted into this is to see the combination of a hyperbola, a straight line function, as well as the parabola. You hardly get these put together like that. So let's explore this and of course highlight some of the techniques one can use to solve these problems. Of course, we are going to be doing question 5. Okay, so first of all, we need to use the doctor's approach. Now, the doctor's approach, we need to hear the story from the horse's mouth, okay? That's the patient giving you their problem, a detailed and focused story. It's not everything, but focused story. Now, we're given the graphs of G. Now, once we see G, this is our standard hyperbola, okay? Right, so we see that this is a over x plus r plus t. So this is a hypothetical equation. So we cannot read much from that equation than to just see it's a hyperbola. But now we try and identify a hyperbola in the given sketch. Now, this is when you are doing inspection on your patient during examination. Do you see this piece and that piece? What do? They approach these dotted lines, but they never cross them. So we call these asymptotes. And asymptotes are never crossed by a hyperbola. Okay, so this indeed confirms that should be G. Of course, what gives it away is that it is identified here. But sometimes it's not identified. Okay, so we know where the hyperbola is. This one right here. Okay. But now, what do we see on this hyperbola? There's not much, but we can see the asymptotes intersect each other at this point D. Now, this is the center of the hyperbola, right? Where we've got those coordinates x and y. So obviously, there are some notes that we can take as we study this. We know that D with coordinates x is to y is the center of graph of G. Okay, why do we know it is the center of G? This is the intersection of the asymptotes. It is always a center. Okay, nice and easy. So this is the one thing that we can identify. Now, we don't have much information to do a lot more, but what we will notice is that we've got coordinates of B here, okay? And we've got A right on the x-axis. So that means there's some x value, but the y value is 0. Okay, and this is on the hyperbola. So that means we can find out what x is here. We can find out both x and y there. And we've got everything. Okay, that's okay. We cannot do much at this point. We move on. Next, we've got f of x equals x plus p all squared plus q. But now we will notice something, that before this bracket, there is an invisible 1. It's usually never written in. That's the a value. A is equal to 1. Effectively suggesting a is greater than 0. And when a is greater than 0, we see that this graph is expected to be concave up, okay? Because the parabola will be concave up when the a value is greater than 0. That's the origin there. So do we see something like that? Again, this is a hypothetical equation, but if we study this parabola, we can see it's concave up. So it matches that description. But again, we don't have much after that. You see D lies on this graph, there's nothing. We see C is on the graph, there's nothing. Looks like a turning point, but we're not sure what it is. Again, we need to think about ways in solving that. Okay, these are sketched below, so there's nothing much we can say here. In fact, if we think about this, the x coordinates and the y coordinates, this is going to be the opposite sign of P and Q as it appears, if this is the turning point, but we will read on. Now the line h of x is an axis of symmetry of G. So if this is an axis of symmetry of G and it intersects G, at those points of intersections with G, we know that essentially A is such that we have the square root of A plus T, just the way it appears there. So it's not T but R is to the square root of A plus T. So as that looks, this is how it is. So we get those coordinates of A like that, and those of B is going to be minus the square root of A plus R minus the square root of A plus T. So we can see that these are already given, so we can use this property in a way. So these are things from the book, guys, that whenever you study these kinds of questions, you make sure you gather as much, especially when given hypothetical equations like this. This can provide us a way of solving simultaneously certain things here to solve for the unknown, okay? It almost always does work, but sometimes it fails, okay? So we continue. Now we'll see something that actually this is a straight line, and this straight line cuts exactly at A. So we can solve for x there. So 3, we will note that A is such that 0 is equal to x minus 1. Therefore x is 1. Therefore A is 1 is to 0. So can you see we have the coordinates of A now? 1 and 0. Can you see? Now we know something. But guess what? There's something we know also. We know that this line from that graph to this graph through this point D. Remember, these 2 points A and B are mirror images of each other about this D point, or a perpendicular line, which is another axis of symmetry. So that if we fold this graph about this point, A comes to lie exactly on B, or B comes to lie exactly on A. So what does this mean? It means the distance DA must be equal to the distance AB. Again, this is something we get from this thing being the center, because if we fit a circle that is tangential to these 2 portions of the graph, it will be the radius DA or BD with the center D. So these are some of the things I speak about, guys, and those of you who have been watching my NBT videos, you'll appreciate I spoke about this in one of the questions that we did. So these kinds of things, guys, are very important. Now this already tells us that our node number 4D is going to be the midpoint of AB, such that x at A plus x at B over 2 is to y at A plus y at B over 2. And so D is going to be, we now know that this is 1 minus 5 over 2 is to 0 minus 6 over 2. Therefore, we know that our D is going to be minus 2 is to, this is minus 3. Can you see? Now we know the coordinates of D by just working with the piece of information given. So this is minus 2 is to minus 3. Can you see, guys? Nice and easy, systematic approach to things. Again, you know this formula from grade 11. Even grade 10s, I see they are doing this midpoint thing. So it's always there, even though it's a concept from paper 2. That's why I'm flagging it. But can you see it applies here? You need to know. And can you see, once we have the asymptotes, we have some step to go now, because from here we can use point B, which was given, to find the equation of G. So we can sort that out now safely. And on top of that, we need to read further. Now, point A is the x-intercept of G, and it is also the x-intercept of H, and hence we were able to use that fact to solve for the coordinates, okay? A and B, with those coordinates -5 and -6, are points of intersection of the graph of H and G. And we saw that we could use this, point number 2, to find those coordinates if we knew what the value of A was and that the value of T was, and all, okay? There's a lot. The axis of symmetry of F, see, axis of symmetry of F cuts the x-axis at A. So, sorry guys for the coughing. So this means point A and point C. Okay, we don't know, but we would assume that is the one. That is the one. So we know that the axis of symmetry cuts the A. Okay? So it means the x-coordinate at A is the same as the x-coordinate at this point right here. And now this already tells us that the coordinate is 1. Okay. And we need to find out Q, because Q now remains elusive. Nice and easy. And we're told C is the turning point. Okay, good. In fact, this is one thing we need to wait for, because this could be any point. Although it looks closer to the turning point, it could be anything. We need to be careful. All right, so that is good. So I kind of ran ahead here. D is a point, D, a point on F, is the point of intersection of the asymptotes of G. Okay, we saw that intersection of the asymptotes, and we have now found it using something you wouldn't expect in this question. So the Northwest has a tendency for these very challenging questions on this particular question. You can check and trace this from as far back as 2022. So they are not really friendly to their students, hey? And in fact, I really commend my student from the Northwest, from the class of 2024. She's got very, very, very good marks. And seeing that they had to struggle through this, even we've done some questions on sequences and series, you could see that this question was unusual as well. Like, okay, this one is not really that bad, because I have shown how to solve questions of this nature from as far back as 2022. So there were some bonuses there. But again, if you use my approach in many things comfortably, you will definitely crack a lot. Don't know what happened. This question 5 is so far away. Anyway, guys, so we can see that, okay, there's a lot we know now, and we can use to our advantage. But after we've examined the patient, remember we ran some tests, right? The questions are the tests, because once we find convincing answers here, then we know we will have made a series of diagnoses that we now know that if you can get the story, examine, and confirm your diagnosis, the treatment is easy, okay? Not always easy, but it's much easier. You will see that some of the treatment plans here that we're going to have to take are horrible sometimes. But you can tell that there you need to be like one of the best to solve such problems as a doctor. So this already tells you guys the level that you need to rise to so that you can become a doctor if you want, or an engineer. Because imagine if you are very flop, you can create a plane that can crash, okay? So it means you need to flirt with the limits so that you can know the safety zones. Anyway, folks, let's put it to the test now. 5.1. We need to determine the coordinates of A, and we saw the approach. We can say A is such that h of x is equal to 0. Y, it is the x-intercept, okay, of h as well. So this implies h of x is what? X minus 1 equal to 0. Therefore, x is 1. Therefore, A is the point 1 is to 0. Done. Pay attention to how I phrase my arguments, and that leading to something that leads to yet another thing. You know, maybe we can stop this thing here and say here, we can deal with that this way. Of course, guys, we're getting 2 marks. So equating h of x to 0 and substituting correctly, and then writing the coordinates. But you can still get the mark here. The final answer may not get a mark, even though it has to be shown as the ordered pair. Please separate the coordinates in the ordered pair with a semicolon. Don't use a comma. Okay, 5.2. I know it's acceptable in certain levels of study, but for high school maths, please don't, because anything else is going to be controversial. I have shown it in the past, so watch some of my videos, you will get the idea. Next question says, show that the coordinates of D are given by... My Lord, we did it. Can you see? Can you imagine? 2 marks, guys. But look at how hidden this question is. A concept from analytical geometry, but by just knowing this is the center. I think I've been shouting this story for a while, and now somebody was listening and then decided to punish students, right? So can you see it applies? And in fact, as much as this looks small, this is a higher grade question, guys. You wouldn't see it, although there's not many marks. Okay, let's move on. Let's see. We know that D is the midpoint of AB. Why? It is the center of G. This is the center point. Let's call it. This is the center of G. The graph of G. Okay? So if we know that this is the center, we've justified this. This is such that. This is a very big statement we need to underline. Such that we know that D is going to be x at A plus x at B over 2 is to y at A plus y at B over 2. Please show these formulas before you substitute. This implies that D is going to be x at A is 1 minus 5 divided by 2 is 2. 0 plus minus 6 is going to just be minus 6 over 2. So therefore D minus 4 divided by 2 is minus 2. Minus 6 divided by 2 is minus 3. Indeed. This is very good. Can you see when you analyze things, we don't struggle. Now this is good. And this already proves that we are correct about A. Because we used what we found to solve the next problem, and it is true. So this is a way of convincing you. They know that this question was tough, but now the examiners are trying to also tell you that if you got it right at A, you will get it right at B. And this confirms that A was also correct. Okay, not a problem. So easy 2 marks, guys. So this substitutions into an identifiable formula and answer. We get our 2 marks. We move on. So 5.3 says we need to show that determine the equation of G. All right. So we know that G of X is now A over. We saw that D is the center, so we take the opposite sign of that value as X plus 2. Okay, here we take this as it is there from the center, so this is minus 3. So I'm just trying to show that we substitute these ones like that, but do you see here the sign has changed? That's the only difference. Now we know that there's a point that was given, so always take the point that was given. Minus 5 is to minus 6. But we can use A now because 5.2 confirmed that A is correct. So once you know that point is correct, you can use it as well. But always use what is given so that what is new, should it be wrong, you don't get yourself in trouble. So x is essentially minus 5 plus 2 minus 3. Now this implies we transpose the 3 minus 6 plus 3 is going to be minus 3 over 1 equals A over minus 5 plus 2 is minus 3. Then we cross multiply. We can confirm that our A is equal to 9. Okay. Nice and easy. So therefore we know that G of x is going to be 9 over x plus 2 minus 3. So that's a very easy question to handle as well. So now what is important is to know that we have to write the equation of G based on the coordinates of D, the center, because the asymptotes are read from there. Then substituting this point B into that format is good. And then the final finish. At times this can be considered for the mark so that you lose, the final answer is not necessarily marked because once you solve A, it's obvious what's going on here. So yeah, 3 marks in the bag. Now, as I can say, guys, check this. Prove that the x-intercept of the hyperbola is point A. Now, if we put 0 in there, we transpose 3, it's positive 3 there. Then we're going to have 3x plus 6. We transpose this 9 minus 6 is 3. 3 divided by 3 is 1. So can you see the x-intercept is 1? So you know, if this equation matches that point A, which we've already proved is correct from 5.2, then every time we're moving, we're getting the marks. Be in the habit of checking your work, guys, because you will score big if that's what you do. So 5.4, we need to show that the equation of f is like that. Not a big deal now. So we know that f of x is x. Now we were told the axis of symmetry is through point A. So we will write, this is positive, so we write the opposite sign here. All squared plus q. Again, we have found a point that we proved because this is already given. This is the point on F, so we can use that. So D, which is minus 2, is 2 minus 3, will be such that minus 3 is equal to, where x is, we put a minus 2, minus 1, all squared plus q. So what do we say here? Therefore, q is, this is minus 3 squared is 9. We transpose, it's going to be minus 12 as a whole. So we can say safely, then we know that f of x is equal to x minus 1 all squared minus 12. Now we just FOIL this out. This implies f is x squared minus, okay, let's not even put brackets. It's x squared minus 2x plus 1 minus 12. Therefore, f of x is x squared minus 2x minus 1 plus 1 minus 12 is minus 11. Again, the examiner is trying to ensure that we know this, because they could easily have said, determine the equation of f, and they would not give this to confirm that your answer is correct. All right, how do we score marks here? Again, writing this properly, substituting the point is key, and eventually, guys, the rest of this expansion is not really that important. The mark is actually finding the value of q, and the value of q already gives us the y coordinate at that turning point. So this is minus 12. Okay, so Slowly but surely we're creeping in. Can you see marks are concentrated on the first part? The last part is just rewriting the whole thing and getting to the answer, you know. But I think it's much more compelling to rather ignore the mark there and maybe give it here. It's more compelling. But still, that can be considered. Usually we would go for 4 marks normally for this because, yeah, but let's leave it at that. Now let's go on. Determine the x-intercepts of f, not a problem. 5.5, so we know that x-intercepts are such that f of x is equal to 0, which implies that x squared minus 2x minus 11 is equal to 0. Let's just try to avoid the drifting effect here to make it nice and clean. Now we know we cannot factorize this. We will need the quadratic formula. X is going to be equal to minus b plus or minus the square root of b squared minus 4ac. Okay, all over 2a. So this implies that our x is equal to, now what is b? Is the coefficient of x. So where we see b, we will substitute that. So this is minus into minus 2 plus or minus into minus 2 all squared minus 4 into. Now when we see a is the coefficient of x squared. And this is an invisible one. We normally don't write it. So where we see a's, that's what we're going to substitute. So we'll substitute 1 into. Now c is the constant term as it is. So where there's c, we'll write the constant term, which is minus 11. This is all divided by 2 into 1. Okay, good one, good one, good one. Therefore, x is going to be equal to, now let's put it on the calculator, minus into minus 2 plus the square root of minus 2 all squared minus 4 into 1 into minus 11 divided by 2. So this to 2 decimal places is going to be 4,46, or x is equal to, let's check the other one. The nice thing about these calculators, you don't have to redo the whole thing. You just go and change the sign where it's necessary and you get the next solution. So we get minus 2,46. Of course, we're keeping to the general instructions here because we don't have them in this paper, unfortunately, because it's not a complete paper. You can see somebody else posted it, so they cut some pages out and they didn't organize this page so well. Some pages are far away. Now guys, there's no excuse. We need to prove that these solutions are correct, because if they are wrong, you are going to die. So we take this solution and plug it there, but we can see this is a whole number. So we will round off to the nearest whole number. But the left hand side must effectively be equal to the right hand side. So we will have here 4,46 all squared minus 2 into 4,46 minus 11. I'm getting minus 0,028. Effectively, to the nearest integer, this is 0. So this is good, because it means the left hand side is equal to the right hand side. Now I can accept my solutions. Okay, but now the question said x-intercept. So remember, this is a point and x-intercept is a point. So I kind of rushed here. So we can say, therefore, the x-intercept of f are such that we have 4,46 and 0, and we have minus 2,46 and 0. Always write this in the ordered pair. Okay, but now the key step also is substitutions, because it's mark worthy. Show the formula and make sure the substitutions are correct. Don't find yourself substituting a minus 2 here, guys. For example, and then here you substitute just a 2. Because this is a square, it's not going to affect the answer. But if there's no minus 2 inside this bracket, I will mark you wrong for the correct substitutions, because substitutions must be correct. You don't just get marks for substitutions. They must be correct based on the formula and the expression. So don't lose marks because of carelessness, guys. And then, of course, we can get our marks there and our marks there. So obviously, folks, you need to show this in the ordered pair, because the examiner can decide the marks are here, because the question said x-intercepts, and we know x-intercepts are the points. They didn't say x-coordinates. There's a difference. If it says x-coordinates, then you can just solve for x only. But once we say intercept or a point, we need to show both x and y values. So you will still get marks there if you like, but this must show up. If this is not showing up, you just solve for the x-intercepts only. You'll get 1 mark for both of them. You lose the 1 mark for the ordered pair. But if you do this, you can get 2 marks like that, provided we see this. So this is very important to learn how to answer questions fully and properly. So now these are the intercepts we're talking about. Is this point right here. So this is the positive one, 4,46 and 0. And then the other one is right there. This is minus 2,46 and 0. Nice and easy. Okay. Let's move on. 4.6 says determine the values of f. Okay, let's do it here. Now, guys, look at these questions. These are the higher order questions, right? Because obviously a matriculant of 2025 does not know what f prime x means, but certainly should know what f of x means. Okay, so f prime of x means gradients. Okay, but you will learn calculus, differential calculus to be specific, in term 2. This you should know from grade 10 already. This is y values of the function. So basically, guys, we're saying we're multiplying gradients of the function by its y values, and we must get a value less than 0. So this is possible for 2 scenarios. When we say these are the gradients, I'll just say grad and then y values. This will only happen in a situation like this, when the gradients are negative and we are multiplying positive y values. The answer is negative, which is what we want. Less than 0 means negative. Or the gradients are positive, we are multiplying negative y values, because the answer will be negative. And all of this is something less than 0. So we need to understand this question. As you can see, it's just 2 marks, but it demands a lot of thinking before you can do it. Now you don't need to do the derivative and other things here. All you do, you just go straight to saying, let me just draw tangent lines. A tangent here gives me a gradient at a point, say a gradient at that point, and then do a tangent at the turning point, and then do a tangent at any other side, so that we can be able to appreciate what type of gradients these are. So at this point, we've got that gradient. So this gradient is positive because we can see it's sloping like that. It's an increasing gradient. This one is a decreasing gradient. And how do we define this? We read from left to right and never in reverse. That's how we decide something is increasing or decreasing. So this is a decreasing, because from left to right, this is dipping down. So this is a negative gradient. Now this one is a horizontal line. The gradient is 0. Very key to look at these things nicely, because the graphs are very useful tools in answering these questions quickly than the algebraic technique. Now, what are we saying? We want to multiply the y values with these gradients. Now let's look on the left. Let's say from this x-intercept going this way, what do we see? The gradients are always going to be negative on this arm of the graph. But from this point, if we're going in this direction, mind you, 0 is not included. So we can say, well, from this point, if we go in this direction, we will see that the y values are on the positive y-axis because the origin is right here. That's the origin right there. Ne? So these are positive y values. Can you see it's going to be a negative gradient multiplied by a positive y value? And that gives us an answer that is negative. So this interval is good. We will pick this one. But it's not included. There's no equal sign there. So we'll leave it as an open circle. But now let's check here. So these are the areas to start looking at. Now there we know that this y value is 0, so it's not included, so it's out. But what happens when we go in this direction? We will see that the y values are positive, but the gradients are also positive on this arm. So this is a positive times positive, which is positive, so it's not giving us the answer. So this interval is forbidden. Now we have yet another spot to check now. What happens between this point and this point A? The x-intercept, or should we say the axis of symmetry, because there's still an x value here. Now, we know that if we're going in here, the y values are negative, the gradients are negative, so that gives us a positive answer, because negative times negative is positive. So this interval is not acceptable. It's out. Now what about this interval between these two now? A and this one right here. Can we see there we've got a negative y value and a positive gradient? So that is good. This gives us the answers. So all those intervals that we have marked correct, we write them down. So we know x must be less than minus 2,46, or x is in between point A and that x-intercept. So this should be less than 4,46, greater than 1. Nice and easy. So that is the solution there. Can you see it takes a moment? Because you need to study this graph from all spheres and all angles. And the best way, guys, approach it this way. Of course, I kind of jumped around because of my experience with these questions. But you who is not experienced, try to move from left to right and every time identify intervals that you need. Why is this not included? Because the gradient here is 0. So 0 is not included here. So remember, 0 multiplied by any number is going to be 0. So we cannot include 0 there at point A because the gradients are 0. And the y values are 0 there. That's why we're not including them. Alright guys, so we get a mark for this and then a mark for that. Usually 3 marks, but they're giving us 2 marks, so it's fine. So 4.7. We now need to calculate the maximum value of this business right here. Again, a new matriculant does not know what the second derivative f double prime. Okay? They don't know this, but they certainly know this expression right here because this is a vertical shift of the graph of f. If it is positive, so we're shifting it upwards 14 units. Okay, so again, you would see that this is why this is a higher grade question, but again, it is a bit higher than someone with the knowledge of grade 11. So they wouldn't know how to solve this. So probably for your term 1, if you are a metric of 2025 you won't have questions of this nature. But for a matric of 2025 in term 2, when calculus has been done, this is coming for you. Okay, you will see more of these. As you can see, this was a trial exam. It's gonna come back again. In the finals, it's gonna come back. So for a grade 12 of 2025, these are the questions that are for grade 12 2025. This is a new matriculant. Okay, now it's gone. Yo. So that one is gone. Okay, let's sort it out. Okay guys, so I forgot that when I play with the limits, this thing changes my things on the screen. All right, okay, so of course guys, this is a grade 12 of 2025 with the exception of 5.2, but no, 5.2 is a higher grade question valid for a grade 12, so with this one included, because that question is the higher grade question for grade 11s, so you can deal with it. Whether you want to scream and shout, it's coming for you. Okay, let's answer this question quickly. So folks, what do we know? We know first of all that the second derivative of f divided by f of x plus 14 is going to be equal to. Now we take this. Now those of you who are upgrading, this is for you guys. So we know that f prime x didn't come out nicely. So f prime x is going to be, using the power rule, we multiply the 2 in front. It's going to be 2x. From 2 we take 1, so it's going to be just 2x. Here we have 1, we multiply in front, we get minus 2. Then from 1 we subtract 1, we get 0. So x to the 0 is 1, so essentially 2 is out. Now, a differential, what is this? A derivative of a constant is a 0, so this is out. So this is the first derivative, and then we run this for the second time to get the second derivative. We've got 1 in here, we multiply to 2, then x to the 1 minus 1, that's 0, so 0, x to the 0 is 1, so this is just 2. Again, the derivative of a constant is not, so the second derivative is this one. So we're going to write the answer here, that this is 2 over. Now, the best way to write f of x is that turning point form. I will explain why for this question in particular. So this is x minus 1 all squared minus 12, right? But now we are adding 14 to it. So what does this give us? 2 over x minus 1 all squared plus 2. Now, once we have done this, we're going to ask ourselves, for a maximum value, for the maximum value of f this thing over f of x plus 14, this is going to be equal to what? Maybe we can say then here, because this is us moving on. Then the maximum value of this is going to be, now guys, remember, do you see this is a perfect square? Let me write it so that you can see. So this is x minus 1. Can you see this is a perfect square? Now, should it be the biggest or should it be the smallest for us to get this? Of course, seeing that we have a constant on the numerator, because this was not going to change. The maximum value of 2 is 2. The minimum value of 2 is 2. But now we want this fraction to be a maximum. Now let me just take you through some revision that you can do even during the exam. Take, for example, 2 over 1. This is equal to 2. But take 2 over 2. This is 1. Take 2 over 4. This is 0.5. Can you see as the denominator gets bigger and bigger, the result gets smaller and smaller? Now that's not maximum, isn't it? Because if we would say this is the maximum value of what is on the denominator, then can you see we get the smallest result. But if we use the smallest value of the denominator, we get the greatest result. And yet the question says greatest result, so that means we must take the minimum value of the denominator. And again, we can see this function is a smiling parabola, so it always has a minimum value. And what is the minimum value? Is the value at the turning point. But now look at this. This function has been transformed. So the minimum value is going to be the 2. So we're going to say this is equal to 2 divided by 2, which is equal to 1. And that's it. Very important. Let me show you why this works. Even if you didn't know the graph and the turning points, look at this. This is a perfect square. A perfect square is either essentially 0 or greater than 0. It's either equal to 0 or greater than 0. But now greater than 0, it's a very big number. It's endless. So it doesn't help us. So we want the smallest value this can be. The smallest value it can be is 0. So we substitute this with 0 and then we add 2. Can you see? This leaves us 2. That's how you can do it algebraically. Just remembering this. Or someone may think of it graphically. Say, okay, this is a parabola. The minimum value is positive. So this is a graph like this, right? This is the parabola. This is the y-axis, x-axis, the origin. And of course, I know that my axis of symmetry is here at 1. And I know my y value there is there at 2. Can you see? This is the smallest value of the graph because all other values are bigger than 2. So this 2 becomes the minimum value. So one can look at this algebraically, can look at it graphically. You know. So again, this is just to show how complex this question is, and yet it looks simple. Nice and easy, guys. So let's move on so you understand how we got this solution. So we mean for this to be a maximum, the denominator must be the minimum, because this is something you can check if you're not sure. Always remember that. But knowing this graph so well, you know that a parabola has a minimum value at the turning point, not a maximum value. So that's another guide here that you could easily use to solve this problem. Okay, guys, nice higher order question there. That was 5, not 4, man, 5. Here when. Now, you see, guys, also incorrect labeling will lose you marks, because if you write this in the script, you will be marked wrong, even though this is correct. But of course, a teacher who's fair might not, but you may lose marks in someone who's strict, because it means you are disorganized. 5.8. Now, this is the suplexity. As you can see, this expression is just horrible. So this is already saying a higher grade with 2 stars, because it's going to demand, it's going to tax you, bruh. So you must be ready to be taxed, and taxed hard. You come out exhausted. So Northwest always kills their students when it comes to the parabola. I don't know. They always do this. But let's move on, guys, and see what is going on. Essentially, is going to be Lord of Lords. It says, for which value or values of m will x plus m all squared minus 2 plus m all squared minus 11. Just looking at this expression, just this one, what do you see? There's a striking resemblance of that one. But now what have we done? X has been substituted by x plus m. So this means this is the graph of f horizontally shifted, whether left or right, because this represents a horizontal shift. Okay, But now we either left or right, we don't know, because this is hypothetical. But this is a horizontally shifted, so that it is equal to this one. We can see that this side here is just the graph of h of x, because this is exactly what it was, x minus 1. So these two graphs are equal, and then we want these to have two different negative roots. So this question is packed, guys, and you can see the mark allocation is already suggesting that I am a killer. I am a dream killer, motivation killer, because here, if you don't know what you are doing, this one shows you rudely so that you are a novice, you tata mashanis. Now guys, let's shift, but if we shift this graph, it's gonna fall short, right? So maybe let's extend this one. Let's extend this one. Say, okay, this one maybe goes like that. And we can even extend it this side. And then we stop there. Say, okay, that is our graph of h. Not a problem. That is our graph of h. Maybe let's use this skanda. Okay, this golden color. Going like that. So we're just extending it. We didn't do anything wrong. And then let's get this graph moving. Let's make it purple. So we want to find out in what way must we move this graph. Yes, guys, I'm good, eh? That's why I am almost a plastic surgeon as well. Okay, but to be a neurosurgeon, you must be a plastic surgeon. In fact, you must be a general surgeon, then become an orthopedic surgeon, an ENT surgeon, a plastic surgeon. All right? Because you won't survive in this field if you're not those people. You will do crazy things. Now, let's say we're shifting this graph to this side. Will it ever have negative roots? Because remember, negative roots are the points of intersection. Can you see the points of intersection here? This is positive, it's positive. So these are two distinct positive roots. But this says negative roots here. So let's say, okay, we go back and say, fine. Let's say we shift it so that the x-intercept is sitting at that x-intercept. Right there. So what is that? Now, if we look at it, these two graphs are actually intersecting there. It's a positive and a negative. They are not both negative, as much as they are distinct. We shift it further and say, maybe we place it at the origin there. Once we place it at the origin, can you see? We will have a negative root over there and a negative root here, because the points of intersections, the x coordinates, are negative and they are different. So this is what it means. But is there a limit? Can we shift it further like this? If we do this, yes, we will see that the points of intersections are essentially two distinct negative roots. But once we hit the bottom there, it becomes tangential. Now, once it becomes tangential, it's a single point, so there are no two roots there. There's one root. And if we move this further, then there's no contact between the two graphs. So it doesn't work. So this means we need to find out when this is tangential at that point. If we say that that is the point of tangency, but I think I may have moved it down, yeah. So if we say that is the point of tangency there, so we can say, okay. Let's find out something. Let's just use some unique colors here. Let's say this is the port. This is the limit to which we can shift this graph horizontally to the left. But it already tells us that we need to shift it past the x-axis, essentially. Because if we just do this again, and then copy our graph, and then we put it down here. Guys, there's a lot here to do. You are not going to survive here if you're not strong. So this graph, we saw that we need to push it at least to the level of the x-axis. Right? Right. I mean at the origin there. Because once we have the origin there, we know that this graph is here. But again, just before the origin, it still looks like there will be negative roots. So we are not so sure. So, but we need to move it some distance to the left. And that distance must be greater than a particular point. But it cannot surpass that point. So we saw that, this is the story that this is giving us. But now this very story is hateful. It kills our magic. So now we say, okay, let's move this a bit back and say we move it so that this graph cuts at the y-intercept of the straight line. Now we place it there and pause it. Can you see, guys, there's a lot of work here to be done. A whole lot of work. And a whole lot of planning. I think my battery is dying. Let me just get it sorted quickly. So, all right, guys, so we can see that. Can you see this question is naughty? Now, if we put it there and just plug it there and we leave it, mind you, we are saying, we are placing this graph right where the y-intercept of this line that it's working with cuts the y-axis. This means x is 0 there. And we will see that if we make it like that, this is the limit for this first part. We need to move this graph beyond this distance. All right? Maybe let's take it and say from this point to that particular point, whatever it is. So this point to this particular point. We don't know what that point is, but we know that the y-intercept of the h graph is 0 and -1. So this means this particular point is going to be some x value and -1. I'm sorry, guys, if you cannot see. So this means we need to move this graph more than this distance to the left, because we saw that as soon as we do that to our function, let's show it. If we move it, remember this function was here? Then if we move it to the left greater than, because if we move it just this distance, we'll only have one negative root there, because the other one is 0. The x there is 0. But if we move it just further, can you see? We appreciate now that technically we will be able to have these negative roots that this thing wants. That one and that one. But the key distance to focus on is this distance. Let's call it distance, say k. That distance is k. Let me just mark it. Remember, this distance is from the y-intercept to where that point is. Now our challenge is to find the x-coordinate, because we know the y-coordinate is -1. Our x is what we don't know. So using the graph, guys, is also horrible, because like I said, use those things. We used to buy phones, and then there's that thing that sometimes the cord, you know, that thing that ties the cord, you can mold it. It's soft into any shape, and then you play with this, and then you draw some nice sketches there in your exam. I don't think anyone would punish you for that, because without this, it can become a horrible situation. Trust me. Or if you have a plastic folder, you know, those transparent folder you put things in, so you can actually take this page with this graph, if you can, or draw a graph like that, you put it inside. Not necessarily, yeah. You can put it inside, but maybe get a plastic slide. There's a plastic slides that we used to have. We used to be taught on this, because we put them on a projector and then projects there. When somebody writes here, you see there. So those plastic slides, if you can find them, buy them, then take some colored pencils, because you can put that over here, and then you draw that sketch, and then you move this plastic slide all across, and then place it in different positions. Then you can succeed. So these are some of the suggestions I can give you, because you can ask these even at your school. They probably would have them. So this is a challenging situation. But at the same time, guys, can you see where this line is a tangent there? It means we can also copy this line. So there's a lot of things that we need to do, but I love this thing. So we need to put this line so that it is a tangent to the parabola. Of course, it looks like it's at the turning point, but it's not. it's at another particular point. So there's a lot of things to consider now. So we can say this is the point of tangency, not necessarily the turning point, but we will calculate it and find out. Again, we can see that this point must move across, but not until it reaches that point. So this is another distance to consider. So we can call this distance, this is KL. We can call this distance L. So again, we need to know what this point is. Now this is no longer the turning point. I can remove this because it's going to be misleading us. This is no longer the turning point. This is some X value and some Y value. We don't know what those are together. So we've got a few challenges, guys. And you can tell this question doesn't play. And of course, we know this line must be parallel to the other to actually make sense. Okay, all right, okay. So we can see that we're doing a lot of shifts. We're shifting this graph horizontally to that side, and we're shifting this graph vertically down until it becomes a tangent. And here we need to compare and contrast things. This is why this is a killer question, and I don't know how the examiners do this in the exams. For trials, guys, they're killing you. Northwest, they don't love you guys, but hey, who cares? You said you can do maths, so let's do it. So now, first of all, guys, I think what is key is to find this point right here, whatever it is. But we know that the Y value is -1. So we can use the equation of the parabola before we shift it to find the X value, because we know that that distance is the distance we need to focus on. This is the first part of the puzzle. If we shift this graph more than this distance, K, that side, then we have found our upper limit. Now we want the lower limit. We need to find this distance because we need to be within this distance for the graph to sit the way we have shown it, so that we can appreciate these two X coordinates there that are essentially negative, which is how we can answer this question with the graph. So can you see, guys, it's a bit busy, and I'm doing it deliberately because I need you to see through the thick and, you know, the busy. You need to see what you need to see. So it's not that easy, eh? It's not that easy. First of all, guys, we can see that technically, for us to deal with this, we can just write here and say, well, f of x, maybe let's just write the expression first. We can say that x plus m all squared minus 2 into x plus m all squared minus 11 is equal to x minus 1. Right. This implies that this is f of x plus m equal to h of x. This is it. And we know that this represents a horizontal shift. And we can see that when we shifted this graph to the right, it didn't work out. But when we shift this graph to the left, it does work out. But there are limits to it. Now we need to work along those limits. First of all, we need to find this point when f is 1, because that is the key. Now, what makes you say what you want to say? I don't really care. Okay? We can call this point, can you see we've got A, B, C, D. We can call this point E, right? And then we can call that point F. Okay? So that's it. We can say now let E be the point such that let's say point E with x is 2 minus 1, because we identified that -1, the y-intercept of this graph, is very helpful for us on the parabola. Be a point on F. Okay? Such that we know that F, we saw, okay, let's do this. We know the y value, we want the x value. So such that we're going to have -1 is equal to x squared minus 2x minus 11. Right. Then we solve for x by moving this. So we'll have x squared. Maybe let's move this because it's going to force us to move it. X squared minus 2x. And then minus 11 plus 1 is going to be minus 10 equal to 0. And then we can factorize this. Can we? I doubt. We can't. We can't factorize here. So we're going to use the quadratic formula. Yeah, guys, this one was one of those questions. Minus b plus or minus the square root of b squared minus 4ac over 2a. So you can see these are the questions that take time. You will not win. You will not win here if you don't take time. And don't be anxious, because these questions are going to force you down the path of anxiety. And when it happens, you miss it. You will miss the point. So you've already learned how to substitute into this. So therefore we know that x is going to be those irrational roots there. So let's see. So we've got minus into minus 2 plus the square root minus 2 squared minus 4a. A there is 1, c is minus 10 divided by 2 into 1. And then I get an answer of 4,32 to 2 decimal places, or x is equal to. But remember, guys, I'm not interested in the -1, because the -1 doesn't really help me. So this value I'm not interested, because on this side where point E is, the x is positive, because on the positive x-axis. Actually, we don't really care about this one. Or maybe we can write it. I mean, there's no harm, so that you don't feel like, why am I choosing that and not the others? And you will end up making bad choices, hey? Let me not influence you in the wrong direction. Or x is minus 2,32 as well. But now, what are we trying to establish? We're establishing point E is going to be 4,32 is 2 minus 1, because we saw that the y value there was minus 1. So we know now the coordinates of that point E. Please keep this one in mind, because it's going to be very important. Now, can you appreciate that the distance k here is essentially, because remember this is from 0 to point E, so this is exactly the distance k. But now I'm just marking a distance k for you to see. I'm not going to use that. I'm going to use this point. So we can see that we have found the value of m. M needs to be greater than this value. Right. Because this is going to form our lower limit. It has to be greater than this, because if we're saying greater, that means this extended, so that we'll end up somewhere like this. Because if we just move this distance only, we will only have this x-intercept sitting here, and so we only get one negative root. So we need to move more than this distance, and this is the distance that we see. That's the first part. Now we want to find out, what is this x coordinate here? What is that x coordinate there? But the good thing is, we also need something. We need to find out these coordinates first, because without these coordinates, we won't be able to know the y value here, because at f, we know that it's some unknown x, but the y value at this point, whatever this point is going to be the y value right there as well. So let me just highlight that this y value is the same as that y value, because this is the horizontal line. So this question, guys, was a killer, believe me. What are we going to name this point? We've got E, F, G, and then we can call it point H. We can say also, so remember, you need to be elaborate here. This is a conversation with your marker. Also let point H with coordinates x and y. Be the point of tangency between f of x and h of x. Because we know that this should be the point of tangency between the two graphs. Of course, we would know that this is f transformed, or we could be talking about that point, we could be talking about this point, but what we're interested in is the y value actually. We really don't care about the x value that much, but it does come to effect because we need it here. So this question is hard, Anyway, guys, now this is a bit vague because we can see that this is starting to spell out trouble because h of x needs to be transformed as well, in a way. But all we care about is that the gradient of this graph must be equal to the gradient of this line. That's all that we care. Because whether shifted or not, we can easily say plus, say for example, q. Because this h must be transformed for it to get there. But what we're trying to do is to get the gradient, right? Right. So such that now we know that essentially the first derivative of f is going to be equal to the gradient of h of h of, okay, maybe let's say, I'm trying to be as elaborate as possible. Let's say this is going to be, say, z of x, which is equal to h of x transformed. Yeah? So this is now going to be the gradient of z. Okay, and now we know that this z implies that it's going to be equal to x minus 1 plus q. All right, but now what we're interested in is the gradient, which is 1, invisible 1. So this means we do the derivative there. What was the function here first? So it's going to be 2x minus 2 is equal to 1. Right, so this implies 2x is going to be equal to essentially 3. When we transpose the 2, therefore the x coordinate is 3 over 2. Easy. So we know that this x coordinate at h is 3 over 2. So we want the y value. Now, what do? We take this back into the parabola again. This is helpful, eh? So we can say therefore y is going to be equal to f of 3 over 2, which is going to be equal to, okay, let's do it systematically. This is 3 over 2 squared minus 2 into 3 over 2 minus 11. So yeah, guys, this one is, I don't know why they asked this question. I really don't know, because I don't think there's an easier way. I doubt. 3 over 2 squared minus 2 into 3 over 2 minus 11. So this gives me minus 47 over 4. Okay, nice and easy. So this, you can do it in decimal what? So this one is 11,75. So maybe let's do it that way so that we don't end up with these fractions. I hate them. So this is basically minus 11,75. So we can say therefore point H, which we introduced, is going to be 3 over 2, which is 1,5. Let's just write it out nicely. So this is 1,5 is to minus 11,75. Can you see why this notation becomes key? Because look at your numbers, they have a comma. Imagine you'll have 3 commas here. That doesn't make sense. It's wrong. In fact, it's dirty. It's not sightly. So do sightly stuff, guys. Don't be people who do unsightly things. Can you see, guys, I introduce everything before I talk about it. I let things be and explain exactly what I'm doing, and then I go on, because after the end of this we can say such that this is the story, and then we move on, because we know at the point of tangency they will have equal gradients. Can you see this helped us to find the 2 coordinates, because now this is also minus 47 over 4. Now we know that this y value also is minus 47 over 4. So we want the x coordinate. We can say this implies how do we set this one up, guys? Okay, now we've said also but the x coordinate here lies on the line of h, right? Right. So we can say then let f with coordinates x is 2 minus 47 over 4 be okay, don't even say let. If you write f, you've indicated it, it's there, guys. Should be. Then f is gonna be like that. We can say is the point of tangency of h and f of x plus m, because we know that that one would be the one transformed so that this becomes the point of tangency, such that, what do we know? We know that essentially h, you can say minus 47 over 2 over 4, is going to be equal to minus x, x plus 1. We're using the graph of h. Yeah, guys, this is a bit cumbersome now. It's horrible. So what is the x value here? Therefore, x is going to be equal to transpose 1 there. So what do we get? Minus 47 over 4 plus 1 gives us minus 43 over 4. So this is minus 43 over 4, which is equal to minus 10,75. Okay, so that means our f here is going to be minus 10,75 and this minus 11,75. See, we are working slowly but surely. Now, guys, these are horizontal distances. It's just a matter of these values. So now we know for a fact that essentially these x values will give us these distances that we want. All of these x values that we found are going to give us the distances that we want. Okay, all right. Now we know that, okay, all right. Now these are the limits. We know we must be more than this value, which is as good as this distance we found over there. But now we know that we need to move greater than this because it has to go that way. M must be positive. Why? Because a shift to the left in the function moves the graph to the left. So M must be positive, and these are positive values. So we can say here, therefore, to answer the question, M must be less than this bigger distance right here. So that distance is going to be the x coordinate here, which is 1,5 minus into minus the x coordinate there, which is this 10,75. I hope you get it, guys. This is getting it up. Maybe let's do it better. It looks horrible. So this is going to be essentially 1,5 minus into minus 10,75. And then this must be greater than this distance, k, which is effectively just that x coordinate, which is 4,32. Okay, this question was hard. Therefore, we know m must be less than. You can see 1,5 essentially plus 10,75 is 12,25. And then, of course, greater than 4,32. Okay. So yeah, you can see, guys, to walk through this one was a painful exercise. There's no shortcuts here. You either know what you're doing, and of course, this forces you to be as creative as possible. Because if you're talking about F, you need to explain what it is and what it represents, so that we can easily see. And of course, you annotate the diagrams as well so that we can see what you're doing. So this question for me was a bit unfair. I don't think it's a very fair question to be put. Honestly, this is punishing students. There's no way, man, kids would figure out this thing that easily. Of course, these are the questions you answer last, guys. You don't answer early, because you can see the amount of work that needs to be done. You need to be sober-minded here. Unless you know you can cruise on other questions, you start eliminating those questions before you take this question entirely, so that you can think about it. But now let me show you another alternative approach to solving this, which is also horrible, because algebraic solutions are also horrible, you know. Because first of all, we're going to say, okay, fine. If we have x plus m all squared, but I always trust my algebra more than these function things, because sometimes they don't make sense. Not because they don't, but because I don't know what to do. But algebra, I'm good at it. I know it was my way to go, because when I get stuck, I would solve it algebraically, because nobody said use the graph only. I can do anything. So now what I'm going to do here, I'm going to simplify this. This is x squared plus this is going to be 2mx plus m squared. We fall this out, it's 2x minus 2m minus 11 equal to x minus 1. Okay, this means we've got x squared. Okay, maybe this one is going to be a bit more simpler. We can move it a bit closer. So this is going to be x squared. Now these are like terms, so we can factorize these out by taking x. So this is going to be plus, we let this one lead. It's going to be m minus 2 times x. So please know how to factorize by grouping. This is essentially, wait, we watch our boy. Let's go systematically. So let's say plus 2mx. Okay, this is still gonna be long, so let's start at the back. So this is x squared plus 2mx. We bring in this one here, it becomes minus 3x. Okay, before we move, we must crawl, right? Then plus m squared minus 2m minus 11 plus 1 is going to be minus 10 equal to 0. And then we solve this now by writing it in standard form. So now we can do it. So we've got x squared plus 2m minus 3x plus m squared minus 2m minus 10 equal to 0. So there's a bit of driftwood here taking place. Okay, it's happening. It's happening whether I like it or not. It's doing it. I don't like my equal signs drifting. I prefer them to be in line so that I can see what I'm doing. It's easy to make mistakes when you don't see what is where. Okay, guys, so this is it. Now this is a quadratic in standard form. Nature of roots in question 1 can be asked like this. We know now that for unequal, because Different means unequal roots. It is such that the discriminant is greater than 0. So this implies that b squared minus 4ac must be greater than 0. Maybe let's not drift it also. So this also implies, now we substitute b. Can you see it's that complex thing? So this is 2m minus 3 all squared minus 4a is the coefficient there, which is 1. And essentially, this is just going to be m squared minus 2m minus 10 greater than 0. So the drifting is just happening, whether I like it or not, and I'm tired now. Now we FOIL this out, it becomes 4m squared minus 2 by 3 is 6, then 2, this is 12, minus 12 m plus 9. Okay, so this is plus 4, minus 4, sorry, distributed in here, we're going to get minus 4m squared plus 8m plus 40 greater than 0. So what do we see? 4m squared takes out 4m squared, and then the rest takes care of itself. So minus 12m plus 8m is basically minus 4m. So this and that. And then 9 plus 40, this is 49. Greater than 0, we transpose, minus 4m is greater than 49. And therefore, sorry, this is minus. When we transpose, the sign doesn't change. But when we divide by negative, m must be less than 49 over 4. Right. That means m is less than. Let's see what is 49 over 4. It's 12.25. Kitchen. But now remember, it only answers the question partially. Because how do we find the next piece? We need to look at the actual roots of this equation. We can say here, however, the roots are such that x is equal to, now we know the discriminant, we're going to move a bit faster, guys. The roots is going to be minus into the coefficient there, which is 2m minus 3 plus or minus the square root of. Now what came out of the discriminant, because now we've done half of the job, so we don't need to do it again. The discriminant came out to be that. So we just plug that as well. So minus 4m plus 49 all over 2 into 1. So this is how the roots. Now here we're moving fast, guys, because this thing is a bit crazy. But now, guys, we are saying this must be negative. So if this must be negative, it means this thing must be less than 0. Okay, maybe let's just write it out like this and say this implies that for negative roots, it should be such that this very thing minus into 2m minus 3 plus or minus the square root of minus 4m plus 49 all divided by 2 must be less than 0. So we are forcing an inequality. Now this is over 1. We can cross multiply when we know the sign of the denominator. But when we don't know it, and also this one, when we know the sign, we can cross multiply because we will know when to change. Now these are positive numbers, so that inequality will not change. So this implies that we've got minus 2m minus 3 plus or minus the square root, because this multiplied by 1 is just going to be 8 all over I. It's not over anything now. The sign still remains. 2 times 0 is 0. Can you see? Now we move this thing across. Just like we solve any radicals, we isolate this thing, so we have plus or minus the square root of minus 4m plus 49 is less than, we transpose that thing, is going to just be 2m minus 3. Okay, because that negative, we just kept it so that we don't confuse ourselves. And then what are we going to do now, guys? We know how to deal with radicals. We square both sides like we do it. See, algebra, guys, is so important. I teach you this. Now remember, whether plus or minus, once we square, this thing is positive, then the square root sign is offloaded as well. So all that remains here is minus 4m plus 49. Now when we square, the inequality doesn't change. We expand this. This is 4m squared minus 12m plus 9. And then we try to write this inequality by making sure it's 0. So obviously when I take this to the other side and rearrange, it's going to be 0 is less than whatever this is. So this means essentially 4m squared minus, now minus 12 plus 4 is going to be minus 8m. Then 9 minus 49 is going to be minus 40. But this time is going to be greater than 0. Unfortunately, this one needs to change when we do this. You can consider this as taking this to that side first and then multiplying by negative. This changes. Or you just know 0 is less than whatever this is once we transpose. So it means this thing is greater than 0, so that we can solve. Now, we can see this is a quadratic, right? But now, this quadratic, okay, we can divide by 4 first. So this is going to be m squared minus 2m minus 10 greater than 0. But now we can't factorize here. It forces you and I down the quadratic. So we can say m here is going to be equal to minus, this time I'm going to just jump in as well. Plus or minus the square root of essentially minus 2 squared minus 4 into 1 into minus 10. I mean, guys, I don't know what the examiners were smoking here. They surely smoked ganja. Otherwise, this is crazy. Therefore, m here, this is the critical values. You can write it that way. Critical values are such that, because at this point, I think it's important, as much as I don't write it, when I can't factorize, I have to write this. Okay, let's see, what do we get, guys? Can you see how many times are we doing the quadratic formula? Okay, maybe once here. But on the other one, I don't know if we did it many times, but yeah. Gross. Maybe twice. Okay, guys, let's finish up. So minus 2 into, okay, plus that into minus 2 squared minus 4 into 1 into minus 10, all divided by 2. So guys, what do we get here? I get essentially 4,32, or x, sorry, not x, but m. When we solve for m here, it's going to be equal to whatever this is. This is minus 2,32. But we established m should be positive for the graph to shift to the left. So this cannot be the solution for m. So now we go ahead and say, look at our parabola. We know that our parabola, so guys, yeah, this question, ibivuta malangabi izobulala umntwana esikolo ongawazi umsebenzi wakhe. So we can say this is the variable m, and then of course, what is this function? This is the f of m, whatever this is. But maybe let's not say f of m, because it looks as if we're talking about that. No. This is a different function. Maybe we can call it P of M. So what will this graph look like? Again, we see negative roots and stuff, but where's the axis of symmetry? Is on the positive side. So this is something like this. All right, so good. So obviously, guys, here we've got 4,32, we've got minus 2,32. And now we're saying we want this graph to be greater than 0, right? Where is it greater than 0? It's less than 0 below, it's equal to 0 here. And if we go in this direction, can you see this is the part of the solutions? So we can see that essentially we can make a conclusion that therefore M must be greater than this 4,32. But now remember, this is working together. There's an intercept here less than this, greater than that, so we can write that M must be less than 12,25, greater than 4,32. Now you can see, guys, this is punishment. I don't know why they put this question here. The quality assurer. The quality assurer is a bad person in the Northwest. I would love to see your face, ma'am or sir, because I gag. This, not even the best can solve this question fast. Unless there's some magics I don't know, which I doubt exist for this level of study, of course. But hey guys, I have shown you that whatever I have been teaching you, if you can just have enough time to do it, you will be good. And these are very good questions to practice at home. I suppose these should be made into the so-called pre-trials, where you're not really scoring marks if you are doing the exam. Or we should say practice exams. For me, a question like this is perfect for practice exams, so that you can build your strength. But I don't think it's fair for an exam where students will score marks that contribute to their final mark. This for me is totally unfair, because you can see here it's taking me through thick and thin. And if you're a student who doesn't know what you're doing, you are dead here. But as you can see, the graphical method was also quite sketchy and very labor intensive, but it gives the results. And the algebraic one looks a bit less problematic, but if you look at it, it's a long thing, almost 2 pages, guys. So, I mean, it's not a small feat as well. But hey, you are the students, you must learn. Here's the channel. And this gadget is just perfect for the job, because we can demonstrate everything so you can see it and you can start to understand our actions, and you will see how to be creative to introduce things. Okay, anyway guys, I hope you'll leave a thumbs up and you'll practice this paper. I'll put it in the description of this video. I'll see you some other time. Let me answer this dude.